Welcome, everyone. Today, we are exploring a concept I call the architect's baton, which examines the fundamental shifts occurring within software engineering in the AI era. As artificial intelligence becomes deeply integrated into our workflows, the role of the software engineer is evolving from a traditional builder into a strategic conductor. This transition requires us to orchestrate complex, intelligent systems with precision and vision. We will delve into how this new dynamic reshapes our approach to design, development, and systemic architecture in this transformative age.
As we look at the evolution of software development, we are seeing a fundamental shift in where the primary bottleneck lies. In past eras, programming was often viewed through the lens of individual craftsmanship, much like a painter at a canvas. We focused heavily on the act of creative expression and the mechanics of manual labor. Our discussions centered on collaboration models, navigating between the structured top-down approach of the cathedral and the decentralized open-source world of the bazaar. During this time, the ability to master syntax and express ideas through line-by-line coding was the defining skill of a developer. Today, in the AI era, that bottleneck is disappearing. The physical act of typing syntax is no longer the constraint, as AI can generate code at an unprecedented scale. This transition shifts our mandate from manual implementation to high-level oversight. We are moving away from the paintbrush and toward the blueprint. The developer's role is now defined by synthesis, the ability to integrate complex components; verification, the critical eye needed to ensure AI-generated output is accurate and secure; and architecture, the strategic design of the system as a whole. Our value no longer lies in writing the code itself, but in the structural integrity and intentionality of the systems we build.
When we examine the integration of artificial intelligence into complex systems, we must consider the dynamic between the AI oracle and the human architect. On the left, the AI oracle represents a force that possesses vast, instantaneous knowledge. However, this capability is often unconstrained. It lacks an inherent understanding of physical reality, state management, or specific enterprise requirements. It is a source of infinite information without an inherent structure. This is where the human architect becomes essential. The architect's role is to design the structural blueprint and establish the necessary guardrails for any project. By asking highly specific, context-rich questions, the human professional is able to extract stable building materials from the AI's vast data pool. Ultimately, the architect provides the constraints and direction needed to transform raw, unmanaged intelligence into practical, grounded solutions.
Think of the AI as a delirious ghostwriter, an enthusiastic and blindingly fast partner that is eager to generate thousands of lines of unverified code. Because of this, the role of the developer is fundamentally changing. We are no longer authors starting from a blank page. Instead, our work has shifted toward ruthless reviewing and refactoring. Our primary responsibility is now to ensure narrative coherence across the entire system integration, acting as the critical filter that turns raw speed into functional, high-quality software.
Orchestrating the automated symphony represents a fundamental shift in our operational mindset. You are no longer required to play every individual instrument or execute every manual task yourself. Instead, your role evolves into that of a conductor, overseeing a sophisticated ensemble of highly capable AI agents and automated pipelines. The focus shifts toward strategic coordination, knowing precisely when specific data flows must enter the system to maintain harmony. As the architect of this environment, your primary responsibility is to define the vision and structure, ensuring the final system functions with the precision and resonance of a perfectly tuned performance.
As we ascend the abstraction ladder, we are witnessing a fundamental shift in the value of software engineering. The traditional task of translating well-defined English into boilerplate code is rapidly approaching zero value, as AI models can now handle these routine translations with ease. Consequently, professional survival in this new era depends exclusively on our capacity to manage the systemic complexity that currently exceeds an AI's context window. We must move beyond the syntax and focus on the high-level architecture and cross-functional logic that machines cannot yet synthesize on their own.
As we look at the evolving landscape of software development, We must transition from being mere coders to becoming architects of systems. We are essentially conceding the micro to own the macro. In this new paradigm, AI excels at micro-level tasks, such as writing discrete functions and generating specific algorithms. These are the individual puzzle pieces that make up our applications. However, humans are uniquely qualified to own the macro. This involves the high-level orchestration of cloud-native infrastructure, the design of complex state management systems, and the resolution of intricate distributed race conditions. Our mandate has shifted. It is no longer just about the individual lines of code, but about a holistic understanding of the entire ecosystem. We must master how database schemas interact with message brokers, how telemetry flows across services, and how systems behave during degradation under heavy load. By letting AI handle the discrete units of work, we free ourselves to focus on the structural integrity and overarching strategy of our digital architecture.
Mastering systemic synthesis and decoupled design is a fundamental requirement in modern software architecture. To build resilient and scalable infrastructure, designing highly decoupled and composable systems is non-negotiable. This modular approach ensures that each component remains independent, allowing for greater flexibility and ease of maintenance. A key strategy in this process is to apply established design patterns, such as the repository, adapter, or facade patterns. These are essential for cleanly isolating AI-generated logic from the rest of the system, preventing external complexities from leaking into the core application. Furthermore, the goal is to successfully glue together disparate components, for example, bridging high-performance REST backends with modern inter-process communications, without falling back into the trap of creating rigid monoliths. By adhering to these principles, we can synthesize complex systems that remain agile and easy to evolve.
Implementing forensic debugging and extreme observability is essential for maintaining complex modern systems. When we inherit code generated by AI, we are also inheriting a unique set of challenges, including subtle bugs, memory leaks, and logical hallucinations that can be incredibly difficult to track down. Because these issues often manifest in unpredictable ways, relying on traditional debugging methods is no longer sufficient. Robust telemetry is the only viable path to quickly pinpointing failures in a production environment. To achieve this, it is critical to master open telemetry and ensure that trace IDs are injected across all distributed services. This level of granular visibility allows us to follow the path of every request, providing the forensic evidence needed to diagnose and resolve issues with precision.
As high-level code generation becomes increasingly automated, deep, low-level knowledge is emerging as the ultimate competitive advantage for developers. While AI can efficiently draft boilerplate and high-level logic, it often struggles with the nuanced intricacies of systems-level programming. This creates a critical need for professionals who can identify AI failures, specifically those involving leaky abstractions or inefficient memory allocations that compromise performance. Mastery of memory management and concurrency models, combined with a firm grasp of the fundamental physics and mathematics of the machine, allows us to build robust, high-performance systems that surpass the capabilities of automated tools. By focusing on these machine fundamentals, we ensure that our engineering expertise remains indispensable in an AI-driven landscape.
Engineering strict guardrails and context pipelines is essential for maintaining the integrity of our AI-driven systems. Interacting with AI is fundamentally an ongoing exercise in context management, requiring continuous refinement to ensure accuracy. To achieve this, we must treat our prompts and reasoning paths as deployable code, applying the same rigorous versioning and testing standards used in traditional software development. This approach necessitates the design of automated pipelines with strict validation layers. These layers are critical for evaluating, testing, and sanitizing AI outputs, ensuring they are safe and reliable before they are ever permitted to reach a production branch.
Becoming the creative architect represents a fundamental shift in how we approach developer ingenuity. This evolution requires us to blend the nuanced creativity of an editor and conductor with the extreme rigor traditionally reserved for the architect. By conceding the minutiae of syntax generation, we are no longer bogged down by line-by-line implementation. Instead, we are free to focus our expertise entirely on systemic execution and long-term architectural resilience, elevating the role of the developer to a higher strategic level.